Hi, how are you? We go on our next topic. We studied about Joule's law, H is equal to I square RT. If current and time are constants, then it is directly proportional to R. But in the last class, we understood that resistance decreases, current increases. That is why heat energy increases. That is, resistance and heat is inversely proportional. Resistance is the ability to resist flow of charges. Its symbol is on screen and its unit is ohm. Resistors is a device having resistance. These resistors are arranged different ways in a circuit for changing current or potential difference. The value of color code resistors or carbon resistors are directly marked on resistors or indicated by color codes. The factors affecting resistance are nature of the substance, length of the conductor, thickness of the conductor, and temperature. In a circuit, voltmeter is used to measure potential difference and it is connected in parallel across the instruments or resistors. And ammeter is used to measure intensity of current and it is connected in series as shown. Resistors are connected in series and parallel. First we have resistors are in series. In this, resistors are connecting one after the other. See the part of the video you are seeing in Victor's channel. 3 40-watt bulbs are connected in series. Switch on the first bulb. What do you observe? Yes, no bulbs are glowing. What is the reason? The circuit not complete. When 3 switches are on, 3 bulbs are glowing with the same and less intensity when it is compared intensity of 1 40-watt bulb. Replace 2 40-watt bulbs by 1 60-watt bulb and 100-watt bulb. All switches are on. What do you observe? Yes, 40-watt bulb glow more brightly and 100-watt bulb glow least. Because less power has more resistance. All are connected in series. Therefore, current will be equal. But voltage gets divided as per the values of resistor. That means voltage is greater for higher resistance. Therefore, bulb having less power has more intensity. From this, when resistors are connected in series, the potential difference gets divided. That is, V equals V1 plus V2 plus V3. The current through each resistor will be the same. Therefore, V1 equals IR1, V2 equals IR2, V3 equals IR3. If R is the effective resistance and V is the effective potential difference of the circuit, V equals IR. Therefore, IR equals IR1 plus IR2 plus IR3. I is common, therefore I into R1 plus R2 plus R3. I get cancelled from each side. We get R equals R1 plus R2 plus R3. In short, when resistors are connected in series, effective resistance is the sum of the resistances. Effective resistance increases, potential difference gets divided, current will be the same. If the resistors are the same value, then the effective resistance can be obtained by multiplying the resistance of a resistor with the number of resistors. That is, R equals R into N, where N is the number of resistors and small r is the resistance of one resistor. Next we have parallel connection of resistors. In this connection, resistors are connected in a common point. Let us see the part of the video you are seeing in Victor's channel. 3 40-watt bulbs are connected in parallel. Switch on the first bulb. What do you observe? Yes, first bulb glows. When 3 switches are on, 3 bulbs are glowing with the same and correct intensity of a 40 watt bulb. Isn't it? Yes. Replace two 40 watt bulbs by 100 watt bulb and 160 watt bulb. And all switches are on. What do you observe? Yes, each bulb glowing with its own intensity. That means when bulbs are connected in parallel, potential difference across each bulb will be the applied potential difference, and current gets divided as per the value of resistors. That is, I equals I1 plus I2 plus I3. Potential difference across each resistor will be the same according to Ohm's law. I is equal to V by R, I1 is equal to V by R1, I2 equals V by R2, I3 equals V by R3. From this, V by R equals V by R1 plus V by R2 plus V by R3. V is common, therefore V into 1 by R1 plus 1 by R2 plus 1 by R3. We get cancelled on each side. We get 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3. In short, resistors are connected in parallel. Effective resistance will be the sum of reciprocal of individual resistors. Effective resistance decreases. Potential difference will be the same. Current gets divided into each resistors. If resistors of same value are connected in parallel, effective resistance R equals small r by N, where N is the number of resistors and small r is the resistance of resistors.